from the previous video, we already found the value of b by finding one-sided limit for limit x approaching 0 fx for both sides. And now we're going to find the value of a by using another limit, which is limit x approaching 2 fx, because it's stated that it is exists. So if it is exists, then we can state that limit x approaching 2 from right fx would equal to limit x approaching 2 from left for fx. Okay, we just need to recall back from right of the function. So right of 2, the function is 2x plus 2, and from left of 2, the function is ax squared plus b. So we just need to substitute the function inside. So limit x approaching 2 from right, the function is 2x plus 2. And limit x approaching 2 from left, the function is ax squared plus b. But note that we already have the value of b from the previous solving. So the value of b here is negative 2, so minus 2. So again, we just need to substitute the value inside. So multiply by 2 plus 2 should be equal to a times 2 squared minus 2. Hence, by solving this part, you're left with a equal to 2. So for the next lesson, we're going to learn about infinite limits. Limit of a rational function can be found by substituting the value of x when the denominator is not 0. For example, if you have limit x approaching 2 for a function in rational form, you just need to substitute the value of x approaching here inside the function. Okay, and then you get the answer. How about if when you substitute the value, you have a different value, you get the denominator 0, and you get the numerator another number. For example, if I give you limit x approaching 0 for function 1 over x squared, then I just need to substitute the value of x approaching 0 here inside the function x, then I get the value 1 over 0. So if you get this kind of solution, this is not the final answer. The method of solving this kind of problem is you must take left and right hand side as x approaches 0 in order to find the correct answer. Okay, for example, if I try to find x approaching 0 from left, then I can see that the value of x continues to take bigger value and the fx will continue to increase without bound. So it's increased without bound. Okay, how about if I take x approaching 0 from right? So if the value of x continues to take smaller value, then I can see that the fx will continue to increase without bound. Okay, so graphically, the function of fx appears as below. So I can say that limit x approaching 0. Okay, so this is limit x approaching 0 for fx. Okay, for the function fx is 1 over x squared. So I can say that the function, the value is approaching something bigger and bigger and bigger, which is y is equal to infinity. So when the limit of fx increases to infinity as x approaches a, then this is called infinite limit. So actually, what is infinite limit's definition? So when the limit of fx increases to infinity as x approaches a, okay, so we can say that limit x approaching a for fx is equal to positive infinity. But when the limit of gx, for example, I take another function, decrease to negative infinity as x approaches a, then I can say that, okay, sorry, this should be function fx here. Okay, so when limit fx x is approaching a for fx, then you can see that it's approach negative infinity, decrease to negative infinity, and the answer should be negative infinity. So then what you can say is, as a conclusion, if from the left hand side, from the left side and also the right side, okay, the answer is the same. So from limit from x approaching a from left is f for fx is positive infinity, and also limit x approaching a from right for function fx is positive infinity. We can say that limit x approaching a for the same function would be positive infinity, and the same goes for negative. But if you have a different answer for right and left side, we can say that it is undefined limits. Okay? Alright, so let's have a look. For example, in tutorial question topic 8, so we're going to discuss question 12, which is involving infinite limit. So I'll pick 12a. So the question asks you to find the value of the limit below its axis. So let's give you limit x approaching 4 from left for function 3 over x minus 4 the whole thing square. Okay, so remember, the first step that you need in order to solve limit is you need to substitute the value x approaches any value into the function. So by substitution, okay, let's say I have limit x approaching 4 from left, 3 over x minus 4 square. If I substitute the value, I'll get 3 over 4 minus 4 the whole thing square, which is 3 over 0. So when you have cases of 3 divided by 0, this is not the final answer. What should you do is, there is a method that I created, which is either the answer would be positive infinity or negative infinity. So let's see okay, let us see the way of solving this kind of problem. Okay, the first thing is you need to read the top one. So limit of a constant would be constant itself. So from the top, limit 3, x approaching 4 from left for 3, the answer is 3. So 3 is positive. Okay, and then how about the below one? The same goes. We can read limit of x approaching 4 from left for the function x minus 4 the whole thing square. Then what should you do here is we look at the line number, okay, for 4, okay, and then we're going to look from the left. Okay, what should you do is just pick a number or any number from left of 4. So let's say I'll pick x equal to 3.9. Okay, I'll substitute inside limit x approaching 4 from left for function x minus 4 square. So let's say I pick x equals to 3.9, so I substitute inside 3.9 minus 4 square. Then what did I get is 0.01, which is 0.01 is a positive value, so I'll put here positive. So you just read positive divide by positive, so the answer is positive infinity. Let us continue with question 12b. So they give you limit x approaching negative 3 from left for the function 2 over x plus 3 multiplied by 1 over x squared plus 9. Okay, so by substitution, we just need to check. You have 2 over negative 3 plus 3 multiplied by 1 over negative 3 square plus 9. Okay, when you solve totally, you will get 2 over 0. So 2 over 0, for this case, the answer should be either positive infinity or negative infinity. But which one should you take? So what should you do? The first thing is, you just need to simplify the function given. So you'll have limit x approaching negative 3 from left divided by 2 over x plus 3 multiplied by x squared plus 9. Okay, then the same thing from the previous method. Okay, we look at the top of it. Okay, you can say limit x approaching negative 3 from left for a constant, it's the same constant. So here your constant is 2. So 2 is positive. Okay, then I recall back from the previous method, we look at the below part, the denominator part. So I have limit x approaching negative 3 from left for function x plus 3 multiplied by x squared plus 9. So what should I do is, I draw the line number, and negative 3, I need to refer any value of x from left of negative 3. So what did I pick? So let's say I pick x equal to negative 4. So I just need to substitute inside the function of the denominator. So x plus 3, x squared plus 9. Then I substitute negative 4 plus 3, negative 4 squared plus 9. Okay, when I press calculator, what did I have is negative 25. So for the bottom part, I get negative. So plus divide by minus, of course I get minus infinity would be the last final answer.